Så, nu börjar klockan närma sig 9, eller klockan är 9, så att välkomna hit. Tror vi börjar bli fler och fler här som droppar in. Men jag tror vi kör igång för att kunna hålla tiden här, så att vi håller den tiden som är utsatt för dagens övning. First, I want to welcome everyone. We may have someone who speaks English among our guests today, so but excuse me, I will take the first part in Swedish and then I will let Ralf continue in English. Så jag tänker börja med att introducera då Ramén här och HEROSE som är våran partner i Sverige. För Ramén och HEROSE har varit partner sedan 2019 på den svenska marknaden. HEROSE är ju en tillverkare av ventiler och säkerhetsventiler för gas, ånga och vätskor. Fabriken ligger i Bad Oldesloe utanför Lübeck i norra Tyskland. Och där har de byggt ventiler sedan 1873. Så det är en väldigt gedigen verksamhet. Gammal. Ramén, vi är ju tillverkare och distributörer av industriella ventiler. Vi har hållit på sedan 1968 med det och sedan 2019 då så är vi ju exklusiv och auktoriserad service- och försäljningspartner till HEROSE på den svenska marknaden. Jag har äran att introducera Ralf Dankert-Paulsen idag. Han är Area Sales Manager för HEROSE för Skandinavien. Och utgår också då från Bad Oldesloe i norra Tyskland. Jag tänkte bara säga så att vi håller chattfunktionen öppen. Ni går jättegärna bra att höja handen i den här lilla fina funktionen man har i Teams. Längst upp där. Man kan lyfta handen och ställa en fråga direkt, så tar Ralf och vi. Chatten modererar vi och tittar i hela tiden, och efter Ralf är klar så tar vi och går igenom frågorna en efter en för alla de som är intresserade. So I will now give the word to Ralf to continue with the presentation of today. The stage is yours.
Thank you, Per. Good morning, everybody. As Per said, my name is Ralf Dankert-Paulsen, working for company HEROSE since beginning of 2010. And before that, I worked for a cryogenic tank manufacturer, and before that in safety valves. So industrial valves are part of my professional career after university, and I would like to share some of the knowledge I have gained during that time, and particular about sizing and selection of safety valves. And here I would like to start now. And as Per said, I hope he said it that way, if you have any question, either raise your hand in Teams and then do it immediately, or we answer them at the end of the presentation. If we can't answer your question, we will find out the answer and come back to you after the webinar. Okay, then I suggest we start, not to lose some time, and our today's topic is the safety valves, and to get some more insight, I will have some basics at the beginning, some definition, and then some recommendations for your daily work and how to proceed with safety valve selection and sizing, and making sure the correct function. The bullet point is we are talking about safety devices, so every attention paid to a proper selection, is able to protect people, to protect expensive equipment, and to keep the plant, the process running. And it's not the investment in the safety valves you're making money with, it's the investment into the processes, and the processes needs to run smoothly, and then at the end of the day, it can earn some money for your company Classification of safety devices. Here you see an overview about pressure relief equipment, and if we have a look, you have two working principles. You have reclosing devices and non-reclosing devices. Here you see it's quite easy. Rupture disk is the only safety device which is considered non-reclosing. At the end of the day, if the rupture disk is bursting, you have a big hole in your pressure vessel, and as a consequence, you will lose all the media inside the process, and this can be rather expensive, but rupture disk in itself is a rather cheap solution to protect equipment, and it can release also rather quick areas or large areas of large flow areas. With the reclosing devices, there are direct loaded devices and controlled devices. Also here you have controlled pressure relief systems and pilot operated safety valves. These are not topic of what we cover today, and we have direct loaded safety valves, and here you have spring loaded safety valves, and the other are weight loaded safety valves. A example for a weight loaded safety valve is already the lid on your pot when you boil water for pasta, because the lid is lifted because of the raising pressure inside the pot when the water is boiling, and this is a very simple safety device already. Safety valves are then classified independently from the loading principle. You have different functional characteristics: full lift safety valve, and proportional safety valve. And here we will talk a little bit more afterwards. Another basic principle to understand is the principle of work. We have two forces working against each other. One force is created by the pressure in the system and the area of the sealing, so the disk area, and the counteracting force is the spring force, and this of course is created by the spring constant and the compression of the spring. And with the correct compression of the spring at the factory, you define the set pressure of the safety valve. And I think it's quite simple and straightforward that as long as the pressure force is smaller than the spring force, the safety valve is closed. If the pressure force is exceeding the spring force, the disc starts to open and to lift away from the seat, and is opening the area where the medium can be released into either the atmosphere or to a safe location. What you need to keep in mind, as we usually talk about metal-to-metal seated valves or a disc with a soft sealing material like PTFE or any kind of O-ring. But the key point is as smaller the gap between the spring force and the pressure force, as lower gets the force pressing the sealing surfaces against each other. And when the forces are equal, the disc is somehow floating at the seat, And in this moment, the valve is untied, and you have already visible, or here you can hear already media being released at the exit of the safety valve. For better understanding of the following slides, we need to define some conditions in the working diagrams of the safety valves, and one is the set pressure. And setting the pressure is done by human beings, first of all, and it is done by audible appearance. So when you first time hear the valve whispering or blowing, then this is defined as the set pressure. And I think already here it's quite obvious that double digits behind the decimal is quite difficult to calibrate. And we are not talking about digital devices and electronic devices. It's mechanical parts, and here we already have some limits. And the set pressure and working conditions is specified as a pressure where the valve starts to open, the start of the lift. Opening pressure is the pressure when the valve has fully reached either the necessary lift or the mechanical restricted lift. And at this moment, the valve has the design capacity. So, only then, when the valve is fully open and stable, fully open, at that moment, it has the capacity which is outlined either in the tables on the data sheets or which you can calculate. Closing pressure is always smaller than the set pressure. It is the pressure when the valve will close again, and it is defined when the lift is 0 again. Lift is quite obvious, is the distance which the disc is moving away from the seat. So here you now see all the defined points from my previous slide in one diagram, and here you see a typical open characteristic of a safety valve at a pressure vessel. We have here the pressure inside the vessel. 100% is the set pressure of the safety valve, which is equal to the maximum allowable working pressure, which is the design pressure of the vessel. So if the vessel has a nameplate defining maximum allowable working pressure 10 bar, the set pressure of the safety valve can be any value between 0 and 10, but shall not exceed 10 bar. And as you can see here, the safety valve will start to open at set pressure. And at one point, the flow of the media will create a impulse to fully open the disk from move the disk away from the seat, and this is named popping pressure. So at this moment it gets really loud and noisy. If we continue with the example of 10 bar, if a full lift safety valve then with compressed air is blowing at 10 bar at full capacity, it makes a noise like a starting jumbo jet, and you are right beside the runway. Here you see the lift is flat because it's mechanical restricted. So the valve is at full capacity. Its lift is 100%. And here we still are below the maximum allowable overpressure of the system. And here we have the full capacity of the safety valve. If the pressure, the root cause for the increased pressure is overcome, solved, fires shut down, or any pumps are switched off, chemical reactions are stopped or whatsoever, running out of feed material, then the pressure will go down, and consequently after when the impulse of the flowing media is gone, the disc will fall down and will close again. And this needs to happen at steam and gases within 10%, minus 10% of the set pressure. And consequently, what we and other safety valve manufacturers recommend is that your normal operating pressure shall not exceed 85% of the vessel set pressure. Similar diagrams, but different characteristics, just to also define the different functions of the valves. Here you see a proportional safety valve. As you can see, compared to the other two, it's not rapidly opening to the design lift. It's a more steady characteristic, and the impulse is not as big as on these two designs. And from this characteristic, you can already see a typical purpose for a proportional safety valve, that this valve is recommended to be used on liquids, on non-compressible fluids. The opposite, a full lift safety valve, is fast opening and then immediately reaching the defined capacity, which is compared to the proportional valve also rather big. This valve is used for steam and gases, and also here you can see that the design of these areas where the flow direction is changed is designed in a way that this will create a larger impulse to open the valve. So compared here and here, the media has different touching points and will create a bigger impulse to force the valve open. And in between these two, it's the so-called standard or normal lift safety valve. And this valve has a later opening. So here it's before 5%, and here it's before 10%. And then it reaches also the design capacity and the design lift. If I am too fast or too detailed, please make me somehow aware, and then I will slow down, or if there's any question, please raise them. Around safety valves, as I mentioned at the beginning, we talk about a safety device which shall protect people, equipment, and the environment. We need to make sure that there is always legal framework around safety valves, and this needs to be observed. And it's not specified in the law, but more in technical rules like the standards we have listed here. So we have two major European standards, and then you also can see the ASME code or the API regulation, which is linked to the oil and gas industry. But all of these standards and codes require that the safety valve is or the safety devices ensure that the maximum allowable working pressure of a vessel is not exceeded by more than 10%. And this is a kind of common rule, and we could continue with Japanese standards, Chinese standards, or Russian standards. It would be always the same. So this is a kind of common rule and understanding. Based on this, the safety valves have different tolerances for the opening pressure and the closing pressure, but also especially these closing pressures are very important values and considerations when it comes to stable operation without a safety valve blowing, and tight safety valves. You need to keep your operating pressure below these closing pressures. This is to avoid untied safety valves, and this is to avoid loss of expensive media and disruptions maybe to the production process. So here we have the values again, just to link the values with the diagram. Closing pressure is quite important. This here is an example for steam and gases. On liquids, we can be here at somewhere between 80 and 100%. So the operating pressure needs to be here on liquid systems. Set pressure is always the design pressure at maximum design pressure of the vessel. It can be lower if you don't use the full capacity of the pressure vessel, but it has to be maximum the 100%. And here you see the same tolerances, 10% for the maximum allowable overpressure, -10 for steam and gases for the closing pressure, -20 for the closing pressure for steam and gases, for liquids, sorry. So, and all what I've said until now is independent of the manufacturer. The regulation and the rules are the same for any safety valve manufacturer, including HEROSE. At HEROSE, when you buy a safety valve from us, we do the following testing of such devices, and as we talk about safety devices, certificates are a very important part of the delivery scope. And during production, we do the following tests, or we have done during development: durability test. Set pressure is of course calibrated at HEROSE. We do a functional testing so that the valve is reaching the maximum lift. Afterwards, we do a seat tightness test according to the standard API 527. And as HEROSE is supplying valves for the industrial gases industry and other cryogenic applications, and very often we see oxygen as a media, all our safety valves in the cryogenic segment are free from oil and grease as a standard, which is also part of the certification of HEROSE when we supply them. So now maybe the more interesting part around away from regulation is how to do proper sizing of safety valves and safety devices. I have taken an example of a vacuum insulated pressure vessel for industrial gases storage. So here you have the liquid oxygen or liquid nitrogen. You have the inner vessel, which is the actual pressure vessel, and you have the outer vessel, which is the area in between is vacuum insulated to avoid heat going from the ambient temperature into the liquid nitrogen, for example. And as you can see here, you have safety valve 1 and safety valve 2 protecting the inner vessel against overpressure. And when you now want to do a sizing of these valves, you need to consider what can happen to this vessel. And one event could be that when the trailer is connected to bring the liquid nitrogen, that the trailer's pump is not stopping for whatever reason. Then the safety valve needs to have the capacity the same or bigger than the trailer pump. Second potential cause for raising the pressure in the vessel could be a vacuum loss. So you lose your insulation properties here and heat is constantly leaking into the media, and this media starts to boil and to evaporate. Then the pressure in the vessel will also increase, and it may reach the design pressure of the vessel, and then the safety valve has to protect them. The same can happen with external fire. So you can have the vessel be surrounded by external fire. And as a consequence of the external fire, you may see also in a additional vacuum loss. And with the external fire, you have a higher heat in leak. For this particular vessel, a failure for pressure increase can also be the failure of this pressure building regulator. If this regulator is stuck, frozen in open position, then this evaporation coil will constantly evaporate liquid and provide the gas into the vessel. And this may also cause pressure increase, or when the liquid nitrogen supplied by the trailer is not saturated at the same pressure as the set pressure, operational pressure of the media, then the nitrogen will boil until it is evaporated, and a lot of volume needs to leave the vessel again. And this will also happen through the safety valves. So a lot of different cases. Each of these cases will give you a value: 100 cubic meters, 10 cubic meters, 50 cubic meters per hour, whatsoever. And with this determined mass flow or volume flow, you can go into the calculation. And for the calculation, you would also need the media state, if it is liquid, if it is steam or gas, or for example, also interesting for calculation, two-phase flow in the safety valve. You need, of course, to know the set pressure. You need to know if there's any additional piping. You need to know the back pressure, and the back pressure, if the back pressure is constant or variable. Variable, for example, can happen if you have a LNG tank and you have a LNG flare, because you don't allow the LNG to blow off into the atmosphere. Then because of the flare operating, you can have variable back pressures, and of course temperature is required for the calculation. And with these input data, you can contact safety valve manufacturers, or you can contact your distribution partners like Ramén, and then these partners or the manufacturer can do the calculations and offer you a proper sized safety valve. And this is always what the pressure vessel authorities and others will look into when you want to operate and you want to get permission of the pressure vessel to be started to operation. Then these authorities always look into such calculations and the sizing. On our side, we support the sizing part of the safety valve design with a free off-charge software. All you need to do is to check our website and then download the media. And for the most typical standards like DIN AN ISO, as I mentioned earlier, we have seen them ASME code section 8 or API 527 and 520. You can do sizing, you can save your sizings, you can print sizings, you can also create your own forms in this software. You have your documentation, what you have done for the different cases, and why you have selected the size of the safety valve. And it's a very convenient tool. What you need to keep in mind when you design a system and you need to design the pipes to the safety valve and maybe at the outlet of the safety valve as well. If I go back, you see here there's a changeover device which will provide some flow resistance. You have a pipe, you have some elbows, you have nozzles, you have other T-pieces. All this kind of equipment may create a flow resistance, and you need to keep in mind that the inlet pressure drop of the safety valve shall not exceed 3% of the set pressure. That is why you very often see the piping towards a safety valve is rather big, and just before the safety valve it might be reduced to smaller sizes because the safety valve not necessarily needs to be that big. So you may have 2-inch piping to a 1-inch safety valve to avoid the inlet pressure drop to exceed the 3% of the set pressure. Back pressure, as I mentioned, you need to differentiate between superimposed back pressure, so a constant back pressure, and a back pressure which you only have when the safety valve is blowing media through piping at the outlet of the safety valve. And what also is very important, the safety valve needs to be properly sized, and maybe lift restrictions shall be used in order to avoid that the valve capacity is exceeding the required capacity by more than 15 or 20%. Because if the valve is too big, you have a spring, you have a disc, so it's a perfect system to reach the own frequency, and then you can watch the safety valve being destroyed within seconds because of the rapid opening and closing of the safety valve. And first, the valve is destroyed, and second, your equipment is not protected correctly, because when the valve is hammering or shattering, the valve has not the required design capacity, so it does not blow off enough media, and in this moment your equipment is not protected correctly. Yeah, this I mentioned already. So as a summary, we have different devices of safety valves. Sometimes you see combinations of them. So for example, on the example with the PNID, I've shown you there are safety valves and bursting discs in parallel with different set pressures. We have different characteristics: proportional, standard, and full lift safety valves, which different characteristics results in different capacities. And so you have different applications. Just to give you another example, proportional safety valves are very often used for thermal expansion of trapped liquids. So if you have a pipe segment between two valves, in case of different thermal conditions, you may have overpressure, or you need to avoid vacuum in this piping segments, then a proportional safety valve would be a good solution for the overpressure protection. When you design systems, you need to consider overpressure and closing pressure differences to make sure that the valve and the system / process can work correctly. And the function of a safety valve is influenced by inlet pressure drop, by the back pressure, and by oversizing. So this brings me to the end of my presentation, and we now have something like 10 minutes for your questions. Thank you very much for the moment.
Tack så mycket Ralf. Väldigt spännande, man lär sig alltid något nytt. Vi har väl inga frågor just nu i chatten. Jag vet inte om det är någon som har någonting de vill tillägga eller fråga om. Annars så är ni väldigt välkomna att höra av er till Ramén, till oss här, eller så att säga på något sätt höra av er till och ställa era frågor på annat sätt. Jag tänkte, om det inte var någonting som kommer kanske här, så tänkte jag göra lite reklam för den uppkommande processteknikmässan som är då till nästa vecka, men veckan efter det. Den ja, där. Då har Ramén en monter tillsammans med HEROSE på processteknik i Göteborg. Jag hoppas ni har möjlighet att komma förbi. Jag hoppas ni har möjlighet att komma förbi och träffa mig och Ralf där. Vi fick in en fråga, Ralf. We got a question now. Is it possible to show the software with an example?
Yeah.
Yeah, we have like 7 minutes to go, so maybe if it's possible.
Yeah, I'm not very good in using the software because it's not my daily work, but I will try. I tried it earlier and now I have a mistake, so I'm afraid I can't show it. No, I have an error.
Ja,
I'm sorry.
vi får säga så, jättevälkomna att höra av er, så kan vi köra ett separat visning av själva programvaran. Det går jättebra. Vi fick en till fråga här. Another question. Any restrictions in installing the safety valves, like horizontal or vertical?
In the standards, it's specified it has to be vertical upright, so the spring is always pointing upwards. Very few safety valves have a approval for other than that installation. So at HEROSE, if we have a range of 20 safety valve types, there's only one type approved for horizontal installation. You need to take care when you look at the design of a safety valve, the connection between the disc and the stem is flexible to avoid or to make sure that you have a correct alignment between the disc and the seat, so that they are always in parallel, and you can, with the flexible connection, you can take away the manufacturing tolerances. And if you put something like this in a horizontal position, the disc can tip and the valve potentially cannot close correctly. So there's a risk for this, and therefore manufacturer typically mention if they allow other than horizontal upright, vertical upright installation positions.
Okay, så alltid vertikal montage då. Annars måste man ha en godkänd ventil om det ska gå horisontellt eller någon annan riktning. Ja, då tror jag vi har...
There was one more question, if I am not mistaken.
Yes, one more. Could you mention when the application of combination rupture disk and safety valves shall be used?
Yeah, the question now is if you have in mind, like I have shown that rupture disk and safety valves are in parallel, then the bursting disk is just the very last safety device in case everything else is failing. And but there's also another combination that the safety valve and rupture disk, the rupture disk is installed at the inlet of the safety valve. Then you can protect the safety valve, for example, against very corrosive media, and you can make sure that you have a 100% tight system, because the bursting disk typically is 100% tight. And then if in case the pressure is increasing, first the bursting disk will pop and then the safety valve will start to open and also close again. But then you need to check the rupture disk after such an event and replace it. So there are two applications. One is to use a cheaper, for example, stainless steel safety valve, and you use a PTFE covered rupture disk for corrosive medias. So then you need to clean the safety valve after such a bursting event, or it's used as a very last exit as it was shown in my PNID. Shall I go back to this or is the question answered?
Så egentligen då är det alltså två applikationer. Det är en applikation när man använder sprängbläcket som sista anhalt efter säkerhetsventilen, eller så använder man sprängbläcket för att skydda säkerhetsventilen till exempel mot korrosiva media.
For example, sorry Per, for example here in this case, if the pressure vessel has a design pressure of 18.5 bar, then the safety valve is calibrated to 18.5 bar, but during pressure testing, the vessel has seen hydrostatic pressure test 1.5 times 18.5 bar. So the vessel itself can withstand 27 bar in maximum. So you put the bursting disk at 27 bar. In case safety valves are failing for some reason, for whatever reason, you don't want the inner vessel to burst, and then you put 27 bar bursting disk here, so that before the vessel burst, you get rid of the media and the overpressure, and can then make sure the equipment is still intact after this event.
Ja, känner att ni fick svar på frågan? Ja, inga fler frågor just nu då. Vi får se här. Så är väl, och jag ska då säga till alla att vi kommer ju skicka ut ett uppföljningsmeddelande till alla, och då kommer det finnas en länk där med hela den här presentationen som Ralf har gjort på YouTube. Så länken till YouTube kommer att finnas där, så det går ju att gå tillbaks till det här och scrolla sig igenom till kanske de sektionerna man tyckte lät mer eller mindre intressanta. Och titta. Och absolut, vi finns alla här för att hjälpa till om det uppstår några andra frågor. Speciellt om programvaran, så går det bra att ladda ner den. Det kommer en länk till den också. Och känner ni att det där är lite för komplext, så går det jättebra att kontakta Ramén, så hjälper vi till. Antingen att ni får introduktion i programvaran, eller att vi hjälper till att utföra beräkningarna åt er. Men annars så tror jag we thank you, Ralf, for this excellent presentation, and we hope to see as many of you as possible in Gothenburg then in 2 weeks.
would be my pleasure, and I hope it was some value provided, some insights about safety valves.
Absolutely, I agree. You get some applause there. That's good. Okej, tack så mycket allihopa. Vi tackar för idag och önskar en fortsatt trevlig torsdag och hoppas vi hörs snart igen. Tack så mycket. Hej då!